Today's lesson is a continuation of CPCTC, and then we're also going to learn the last congruence postulate for proving triangles congruent, which is called HL. So before we do that, let's go over some parts of a triangle. So the two parts of a triangle we're going to learn about today is called the median and the altitude. So the median is a segment from a vertex of a triangle to the midpoint of the opposite side. So remember that these parts are the vertices of a triangle, right? They're the corners. And there's 3 of them. Okay. So a median is drawn from one of these vertexes to the midpoint of the opposite side. So what happens then is it splits us into congruent parts. So we can do the same thing from A across to the opposite side, 2 congruent points, because remember a midpoint divides a segment into 2 congruent parts. And then C across, there we go. So notice that the triangle has 3 medians, and each triangle will always have 3 medians. So what do we do in a proof if we're given a median? So if median then connects with midpoint of opposite side. Okay. If we're trying to prove that a segment is a median, then we would say if a segment from a vertex divides the opposite side, into 2 congruent parts, or just in 2 congruent segments, that's fine as well, then it is a median. Okay, so if a median, then it connects with the midpoint of the opposite side, which means then you would be able to conclude that those 2 parts are congruent. And then if proving that something is a median, if a segment from the vertex divides the opposite side into congruent segments, then it is a median. That would be Wrigley in the background just now. Okay, and altitude is a segment from a vertex of a triangle that is perpendicular to the opposite side. So once again, starting from a vertex, okay, and these are all of our vertices of a triangle. Okay, and we start at the vertex and we go perpendicular to the opposite side. And again, there's 3 altitudes. Now, sometimes the altitude can actually be drawn outside of a triangle, and that happens when you have an obtuse triangle. So when there's an obtuse triangle, remember that means that one of the angles is bigger than 90 degrees but less than 180. And remember that the definition of the altitude was drawing from the vertex perpendicular to the other side. So we extend this past, and that would be perpendicular to the other side. Okay. And again, every triangle has 3 medians. All right, so if altitude, then it forms right angles with opposite sides. And what I just noticed was above this, it shouldn't say medians, it should say altitudes. Okay. And then to try to prove an altitude, same thing, kind of what we said above for the median, that if a segment from a vertex is perpendicular to the opposite side, then it is an altitude. And actually, below in the notes, you can see a diagram now, kind of what I was talking about before, that if you have an obtuse triangle, that the altitudes are sometimes drawn outside of the triangle. Practice examples. Okay. So the first thing we're going to do is we're just going to practice applying what altitudes and medians do to a diagram arithmetically for us. Wow, can't talk there for a second. And then we're going to learn about HL. All right, so let's do some. So it says find AB if BD is a median. So we know the definition of a median states that these two are going to be congruent because a median starts from the vertex and goes to the opposite side midpoint. So we can go ahead and set these two equal to each other. So x plus 3 equals 2x minus 17. So we get x equal 20. But the directions said to find AB. So I'm just going to do 20 minus 7 gives me 13. Okay. And then the altitude, remember that an altitude forms 90-degree angle with the other side because it's perpendicular. So we're going to set this part right here, because we know that this is going to be perpendicular, equal to 90. So 4x plus 10 equals 90. So x equals 20. And then from there it says find BC. So BC is this full length. So I'm going to plug 20 into both. So I get 40 plus 60 minus 4, which gives me 96. Okay, our last congruence postulate that we need to learn is what's known as the HL. So all of the congruence postulates that we have done so far has had 3 components. The HL looks like it only has 2 components, but it really has 3. Okay, so first of all, it needs to be a right triangle. Okay, in order to use HL, it has to be a right triangle. The side across from the 90-degree angle is known as the hypotenuse. And then each one of these sides is known as a leg. You can only use the hypotenuse leg postulate, that's where HL comes from, if you have 2 right triangles, you can prove the hypotenuses are congruent, and you can prove one pair of legs congruent. If you don't have one of these components, you cannot use HL. And there's going to be some times where you do have a right triangle and you can't use HL. Okay. On a diagram, what it would look like is that you have right angles. Okay, so you know it's a right triangle. The hypotenuse is always across from it, so this would be congruent. And then it doesn't matter which leg as long as it's the same leg that's congruent. All right, let's get into our 2 proofs. We'll be done with the notes. Okay, so first of all, let's start with our given. So BC is perpendicular to AD, and BD is perpendicular to AD. And then we have AC is congruent to AD. So the only thing I can mark on my diagram right now is that AC is congruent to AD. The fact that something is perpendicular, I have to break that down first. I have to dissect it. So my second step is going to be that angle ACB and angle ADB are right angles. And the reason being the right angles is because of the definition of perpendicular. Now that I proved that, I'm going to mark this. Okay. So in order to use HL, I need to have the hypotenuse and the leg, or a leg. The hypotenuse is the one across from the 90-degree angle. Well, can I prove the hypotenuse is congruent to itself? I can, by the reflexive property. So AB is congruent to AB by the reflexive property. So now I can use HL because I have right triangles. I have the hypotenuse. Remember that the hypotenuse is the one across from the 90-degree angle. And I have a pair of legs congruent. So I can officially use HL. Oops, that's the other part. So triangle ACB is congruent to triangle ADB by HL. So the hypotenuse we proved in step 3, and then the leg we proved in step 1. Well, now that we know the triangles are congruent, remember that our whole goal was to get to prove that CAD was bisected. In order to do that, we needed to prove that angle CAB was congruent to angle DAB. And we can say that by CPCTC. Now that those two angles are proven congruent, we can say, and sorry that I'm running out of room right here, that AB bisects angle CAD by the definition of an angle bisector. So very similar to what we were doing yesterday, we were just adding on to it with the fact that now we have another congruence postulate for only right triangles. Okay. All right. Last proof. And actually, you know what? I think I'm going to go over this proof with the class as a whole. I think that'd be a good idea. So we'll just end it there. And I hope you all have a wonderful day or wonderful evening or whatever morning, day, night it is. Thank you.